Okay, so goals for today. I can determine the weight and mass of an object on Earth and on other planets using Newton's second law. Agenda for today, you're going to take notes on finding the weight and mass of an object on Earth and on other planets. Then you're going to complete practice problems on finding the weight and mass of an object on Earth and on other planets. Okay, so in the force of gravity labs, we learned that most objects on Earth accelerate at the same rate, and this is as a result of gravity, right? So gravity affects all things on Earth at pretty much the same way, that rate of acceleration is 9.8 meters per second per second. So we call that rate g, and so that's just how fast things accelerate when we drop them on Earth. This is often approximated as 10 meters per second per second. Now, as we saw in the lab yesterday, some objects, like flat pieces of paper or feathers, will accelerate much slower than this, and that's because their shape causes a significant amount of drag. And this is also known as air resistance. So we look at some objects, some really light objects that have a lot of surface area, and what happens is as gravity pulls them down, the air, their shape catches the air, and then that air pulls back up, and so that slows their fall, and we call that force drag. That's pulling against gravity when they're falling. Okay, the moon has 1/6 the gravity of Earth. So objects on the moon accelerate at 1.6 meters per second per second. So on Earth, they accelerate at 9.8 meters per second per second. On the moon, they accelerate at 1.6. The gravity on Jupiter is over twice as strong as the gravity on Earth. So objects on Jupiter accelerate at 22.3 meters per second when they fall. So much faster than they do on Earth. No matter where you are in the universe, your mass will be the same. However, your weight is determined by Newton's second law because weight is a force, right? Sometimes it's referred to as the force of gravity. So we're going to be calculating the weights of different things on different planets today. And we're going to be using this formula for the most part, F equals m times a. And this comes from Newton's second law. And so we can see from this formula that if you have more mass, so if we increase the mass, then you will weigh more, right? Because the force will be more. If you increase m, you'll increase F. Similarly, if you are on a planet with stronger gravity, so if the A or the G on that planet is larger, right, the acceleration or the gravity is larger, well, if you increase A, you're also going to increase F, so you will weigh more, right? So more mass, you'll weigh more. Stronger gravity, you'll weigh more. Okay, so here's some formulas that you're going to need for today's lesson. We're going to use that Newton's second law triangle. So F goes on top, M and A goes on bottom. The main equation that we're going to be the main variable that we're going to be solving for is F, because F, or the force, is the weight, right? So we're going to be solving for a lot of weights today. If we cover that up, F equals m times a, mass times acceleration. And just to be clear, all the accelerations are going to be the accelerations due to gravity. So on Earth it's 9.8, on the moon it's 1.6, on Jupiter it's 22.3, and then you're going to solve for some other planets or moons. Okay, if we cover up m, we get F divided by A. We're not actually going to use this formula today, but it's important to know that you can get 3 formulas out of this triangle. And the last one, if we cover up A, we get F divided by M. Okay, so those are the 3 formulas that you'll need to know. And then one last thing that you'll need to know today is that on Earth, 2.2 pounds equals 1 kilogram. And you'll need to know that so that you can find your mass in kilograms, or find the mass of some objects in kilograms. And we're going to use that right at the beginning here. So 2.2 pounds equals 1 kilogram. So in example 1, Mr. Brunswold weighs 180 pounds. So we're going to use this equation to figure out what my mass is in kilograms. We're going to divide my weight in pounds by 2.2, and that will give me my mass in kilograms. So we're going to do 180 divided by 2.2, and that's going to be 81.8 kilograms. Now remember, whatever your mass is on Earth, it'll be the same everywhere else in the universe. Your mass doesn't change. Your mass is how much stuff you're made up of, how much matter is in your body. And so that won't change no matter where you are. So your mass on the moon is also going to be 81.8 kilograms. Your mass on Jupiter is also going to be 81.8 kilograms. Your weight, however, will change. So if we calculate my weight in newtons on Earth, we need to start with my mass, 81.8 kilograms, and then we multiply that by the acceleration due to gravity on Earth, which is 9.8. So 81.8 times 9.8 equals 801.6 newtons. Okay, now let's do the same thing for the moon. So we're going to start off with my mass, which is 81.8. And then the acceleration due to gravity on the moon isn't 9.8, it's 1.6. So if you're confused about this, just scroll up to your notes and you'll have it written up there. So on the moon, it's 1.6. 81.8 times 1.6 equals 130.9 newtons. On Jupiter, on the other hand, we're going to start with 81.8, but instead of multiplying by 9.8 or 1.6, we're going to multiply by 22.3. So 81.8 divided by 22.3, right? We're just taking the mass times the acceleration. And we're going to get 1,824.1 newtons. Okay, so then last up, Mr. Brunswold is teleported to a strange planet where his weight in newtons is 417 newtons. What is the acceleration due to gravity on this planet? So we're solving for acceleration. So if we cover up acceleration, we're left with F divided by M. So acceleration equals force divided by mass. Acceleration equals 417 divided by 81.8. So the force came from right here, 417 newtons. The mass, that came from this page right here, right? Same mass as before, 81.8. So we're going to do 417 divided by 81.8. And the acceleration will end up being 5.1 meters per second per second. So this unknown planet has a gravity of 5.1 meters per second per second. So that means this planet's about half the mass of Earth. Okay, so next we're going to do an example with a car. So this car weighs 2,850 pounds. So first thing we're going to do is figure out the mass of this car on Earth. We get that by dividing by 2.2. So for all of these problems, your first step is going to be take the weight in pounds and divide by 2.2 to get the mass on Earth. And that would be 1295.5 kilograms. And so that'll be the same on the moon and the same on Jupiter. To get the weight on Earth, we're going to take those kilograms and we're going to multiply by 9.8 because that's the acceleration due to gravity on Earth. We multiply them, we get 12,695.5 newtons. Okay? For this next part, we're going to do the same thing, except instead of multiplying by 9.8, we're going to multiply by 1.6, because that's the acceleration due to gravity on the moon. Multiply 1295.5 times 1.6, and we'll get 2,072.7 newtons. Last up, we'll do it for Jupiter. We're going to do 1295.5 times 22.3, because that's the acceleration due to gravity on Jupiter. And we'll get 28,888.6 newtons. That's how much that car would weigh on Jupiter. The car is being driven by Elon Musk on Mars. There it weighs 4,793.1 newtons. what is the acceleration due to gravity on Mars? So we are solving for acceleration. So our formula is acceleration equals force divided by mass. This is our force, 4,793.1. Our mass was 1,295.5. So we're going to divide those two. 4,793.1 divided by 1,295.5. So then our acceleration becomes 3.7 meters per second per second. So the gravity on Mars is about a third of the strength of the gravity on Earth. Okay. So then you're going to do a couple practice problems. This first one, you're dealing with a German Shepherd dog. It weighs 80 pounds. My sister has an 80-pound German Shepherd. That's what I was thinking about when I did this one. You'll answer these questions about its mass and then its weight on different planets. And then you'll use the mass of the dog and its weight on Titan to figure out what the gravity due to acceleration on Titan is. And then for the next two problems, you're going to pick an object. So you're just going to make something up, right? Maybe you want you to be an object. Maybe you want it to be your friend. Maybe you don't want maybe you don't want the object to be a person. Maybe you want to just, think of something like a ball or a toy, or could be anything really. But you'll write the name of the object here, and then you'll estimate its weight right here. If you don't know, just guess. It doesn't really matter. And then you'll write the object here and its weight again. You'll find its mass on Earth, mass on Moon, mass on Jupiter, weight on Earth, weight on the Moon, weight on Jupiter. And then we're going to say that this object or person is transported to an unknown planet where it weighs 1,000 newtons. What is the acceleration due to gravity on this unknown planet? Okay, let me know if you have any questions.